Good morning. This may be day 2 e-learning, or maybe you're just absent today. It's Tuesday, December 2nd. So let's go with this. This is very similar to the paper from yesterday, only yesterday I was using red and today I'm using blue. And I have gotten rid of some things that you didn't need. We're going to learn how to balance today. So get rid of that. Balancing. And the thing about balancing is you have to have, first of all, you have to have correct formulas everywhere. And you can't change formulas once they're there. You can't just add a subscript or take away a subscript or change a subscript. You can't do any of that. You have to the only thing you can do is put a coefficient, which is a big number, in front of a compound, and that multiplies that whole compound, everything in that compound, by that coefficient. The coefficient does not cross a plus sign or an arrow. So if you put a plus sign or put a coefficient on the first reactant, it doesn't affect anything but the first reactant, and that will become more clear as we go. So here is first reaction. H2 plus O2 makes H2O. What I would like for you to do, and this comes from years and years and years of experience, the best thing to do is write down what you have on each side of the equation, all the elements that you have on each side of the equation, and write down how many of each one you've got. You see, I've got 2 hydrogens, I've got 2 oxygens, I've got 2 hydrogens, I've got 1 oxygen. So the hydrogen right now is in balance, but the oxygen is not. It would be really easy, it would be really nice if I could just make that a 2, but that is no longer water. Now that's hydrogen peroxide. So you cannot change the subscript once it's there. Your formulas must be correct. All we can do is add a coefficient. So how do we get the 2 oxygens on the left and 2 oxygens on the right? Well, all I can do is put a big 2 out front here of the water, which changes this H from 2 to now 4, and this O is now 2. Now look, your oxygens are good, but your hydrogen is now out of whack, and we want it in whack, not out of whack. So how are we going to fix that? Well, we're going to throw a 2 right here, and that will change that to a 4. And now hydrogens are both 4, oxygens are both 2. This equation is balanced. We are finished. That is the answer to this problem. All right, second one, calcium carbonate makes calcium oxide plus carbon dioxide. Those formulas were correct. I'm going to do an atom inventory. That's what I like to call it. Oops. And it is helpful if you write your elements in the same order on both sides. It's just a little bit neater that way and make things a little bit easier to keep track of. So I got 1 calcium, 1 carbon, 3 oxygens. I got 1 calcium, 1 carbon, 3 oxygens. How did you get 3? Look, there's 2 plus 1 is 3. This equation is already balanced. We don't need to put anything. If you want to put something in, you could put 1s in, but 1s are not necessary. All right, zinc plus copper sulfate, zinc sulfate plus copper. We've got zinc, we got copper, we got sulfur, we got oxygen. I've got 1 zinc, I've got 1 copper, I got 1 sulfur, I got 4 oxygens. I got 1 zinc, I got 1 copper, I got 1 sulfur, I got 4 oxygen. This equation is already balanced. We don't need to do anything. They're all 1s. All right, I think we're going to see a pattern here. Here's some silver and some nitrogen and some oxygen and some sodium and some chlorine. And we got 1, 1, 3, 1, 1. Is that surprising anyone? And it looks like everything is already balanced. That was already balanced. All right, I'll bet this next one isn't already balanced. Okay, this is our combustion reaction. I've got carbon, I've got hydrogen, I've got oxygen, I've got carbon, I've got hydrogen, I've got oxygen, I got 1, I got 4, I got 2. I got 1, I got 2, I've got 3. right? There's 2 here and 1 here. There's 3. We have to add those together. All right. So, looks like my hydrogen is messed up. I got 4 on the left, only 2 on the right, so I need to throw a big 2 in right there. Change that to a 4. Now that makes my oxygen also 4, right? Because there's 2 there, and there's 2 there now. Right, there's 2 H2Os. So that makes it 4. So now we got carbon's good, hydrogen's good, oxygen's messed up, but it's been messed up. So, but now it needs to go from 2 to a 4, so I just need to put a big 2 there, and that equation is balanced. MgOH, MgOH, 1, 2, 2, 1, 2, 2, already balanced. Where's the rest of these at? Where are the rest of them? Ah, here they are. All right, here we go. We got K, we got Cl, we got O, we got K, we got Cl, we got O. 1, 1, 3, 1, 1, 2. 2 and 3. There's nothing I can put here, no whole number I can put there to turn this 2 into a 3. So, what do we do in a case like that? We're going to have to, what I like to do, when I see 2s and 3s like this on an oxygen, I'm going to shoot for a total of 6. Usually that total of 6. So to make it 6, I'll need a 3 there. That'll make that a 6. To get a 6 on this side, I need a 2 there. That makes that a 6, but it also makes these into 2s. So now what? It just seems like it's getting worse. Let's cry. No, let's not cry. Let's just put a 2 here. And now we're balanced. 2, 2, 3. See, this isn't hard. FeHCl. FeHCl. I've got 1, I got 1, I got 1, I got 1, I got 2, I got 3. Notice I made it iron 3 chloride, just so it would be more fun to balance. So, my H's, my Cl's. Oh, the Cl's are bad too. I'm tempted to put a 3 right here and make that 3 and 3, but then I can't make this a 3. There's no way to make that a 3 unless I put a 3 here and make that a 6. And then I'll have to put, where's my eraser? Where's the eraser? Oh, there's the eraser. So now what I have to do is I'll have to put a 6 here. 6, 6. Well, how do I get my chlorines to be a 6? Well, I'll put a 2 in front. But that changes the iron also. But that's an easy fix. So 2, 6, 2, 3. 2, 6, 2, 3. Pretty good shape. All right, I'm going to do this one 2 ways. First, I'm going to go P, B, N, O, K, I. One, 2, right? There's 2 N's. 6, 1, 1. 1, 2, 1, 1, 3. Well, it looks like if I would put a 2 right here, now my I is in good shape, my PB is in good shape, N is messed up, O is messed up, K is messed up. So if I got 2 Ks here, I need 2 here, I'll throw a 2 right there. That'll fix the K. But look what it does. It makes it 2 N's, and 2 times 3, 6 O's. So a 2 on the K, both the K's, basically. Now, another way we could do this, let me start over. Another thing we could do PB. What if we keep the NO3s together? So now I got APB, I've got two NO3s, I got one K, I got one I. I've got one PB, I've got two I's, I've got one K, I've got one NO3. Okay, so now if I put a 2, look at the NO3s, watch, if I put a 2 there, that fixes the K, and that fixes the NO3, and then we put a 2 here, and that makes that 2 and that 2. So now everything's balanced. It's not such a big deal on this problem, but sometimes if you've got O in more than one place, but one of them, it's a polyatomic ion, sometimes it's easier to do it that way, where you keep them all together. So we got Al, we got O. All right, so we got 2 aluminum, so I need to put, well, let's do the O's first. 2 and 3, 6. So I'm going to have to put a 2 here to make that a 6, but that makes that a 4. I'll put a 3 here to make that a 6, but then I'll need a 4 there. So that takes care of balancing this set of equations. And hopefully we're doing this in school and not as e-learning, but you never know. So it's ready if we have to do it as e-learning. And then I will see you, Friday is next time I'll see you. If Tuesday is e-learning, I won't see you till Friday. So have a good week.